Hi, I'm Ned, and I've started streaming. This is a recording from my live stream over on twitch.tv/NedMakesGames. I'm live most Mondays, Wednesdays, and Fridays at 10 a.m. US Eastern Time. I'd love to see you there. Okay, hey everybody. I hope you've all had a great weekend. Yeah, my weekend was pretty good. Yeah, nothing really out of the ordinary. Got to have some relaxing time, so that's always nice. But let's go ahead and get started. So I guess just last stream, I was working on my grass renderer, and basically right now the shaders are kind of messy, and I'd like to see if I can clean them up. And one thing I really want to do is try out a better wind system. Like you can kind of tell with this. See, what I want to happen is when the wind moves the grass, the reflection or the specular lighting will also change as well. But right now, when the wind moves the grass, it doesn't really recalculate the normal vector correctly, so it's not super. It doesn't have that cool like ribbon shine effect that you see. So I want to try to add that, and to do that I want to try a new wind system. But I thought before I tried to add stuff onto it, I should clean up all my code, which I had been basically I was making this system and experimenting at the same time. So now that that's all done, I want to try to make everything work correctly. Okay, so where did we stop? Yeah, so these are all my new shaders. I think we had just finished. Let's see here. Okay, so we have one thing. Yeah, about this grass system is there's like a bunch of different versions of the shader, because this shader is well, basically how the grass system works is there's like a hidden camera that's above the scene, and it raycasts downwards on the terrain to try to find places to sprout grass. And you can kind of tell, like, if I move the camera where the well, it doesn't update in the scene view, I guess, because I probably have to have both active. But let's see. Yeah, so well, it's hard to see in this specific case because the color is very similar, but when I move the camera, you can see that the grass blades only follow the camera's view frustum. So in effect, the system has two shaders. It has like a sprouting shader, which is what the camera raycasts down, and it detects like the position of each blade and then puts that data into a buffer. And then there's the actual material shader, which draws the grass, like I guess the colors. So right now I'm working on the sprouting shader, and like I said, there's a few different versions of it, because for optimization's sake, you might want to just color each blade. Well, I'm trying to think how to explain it. So here, each blade is lit like per pixel, so every pixel on the grass calculates a lighting value. But if you want to optimize it, you can only calculate a single lighting value that's shared between the whole blade, and that'll make the grass much more efficient. And since if the grass is small enough, you might not even be able to tell the difference. So yeah, so basically the soil shader, or not the soil, the sprouting shaders have to have two different versions, one for what I call a mesh lit, and then another one for the instance lit version. And then also the soil shaders, or the sprout shaders, can have like the visible mesh for the soil, or here like this grayish color for the terrain, or they can be invisible, so they only have the sprouting pass. So yeah, there's two different versions for that, and then there's like all different ways that the sprouting shader could decide how to create the grass blades. But yeah, all this will well, when I make the tutorial, hopefully this will all make a bit more sense, but I just wanted to kind of quickly go over the system. Okay, so right now we're doing the sprouting system, our sprouting shader, and it has a PBR lit for the visible part of the mesh. And then, but the sprouting part, excuse me, is texture based, which means that it's going to read a texture to see like grass density. And then the blades will be instance lit. I guess I can add spaces in the name. Okay, so we have yeah, and so one of the things I wanted to do when we were rewriting this was to try to combine a lot of these different permutations into a single shader, but it turns out especially like this instance lit, I thought that I could maybe just change between instance and mesh lighting depending on keyword, but that doesn't really work very well because a lot of these multi-compiles we don't need if we're doing mesh lit, and so Unity will spend a lot of time creating shader variants that will never be used, and since it's a multi-compile, it will always be included in the game build, so it's just not the most efficient to do it that way. Maybe there's another way I could try to handle it, which maybe I'll look into. Okay, but for now, yeah, I guess we'll get rid of that. But since this is instance lit, okay, so we have the instance lit. File here. I guess I'll go ahead and define an instance lit keyword here, just so that, because I think some of these other structures, yeah, depend on it, or some of these other files. Okay, so I think I had gone through. Okay, this is actually. Oh wait, no, that's fine. I'm trying to find. Oh yeah, the sprout pass comment is what I'm trying to find. Okay, so I think I had gone through and cleaned up all of this pretty well. We renamed some variables. Just trying to see if there's anything else that looks kind of... Okay, so the soil LED noises, I think I renamed that. Yeah, so I think I should change them to sprout, because I'm kind of changing the name from soil shader to a sprout shader. Really? So, okay, I'm surprised because it said it only changed one place. Okay. I'll have to look into that. So that makes me think that, well, how come do I even need to keep this variable if it's not being used anywhere? Okay, I think I want to change this to like sprout LOD info. And then I think I'll change this to sprout grid cell size, because since we use like random noise to randomize each grass blade, it small changes in values can kind of cause the grass to flicker, so you have to try to snap them all to the specific grid. Or at least the random values. Okay, so that means, yeah, so some of this stuff. Okay, so if I change these names, it's not going to, like the current grass shaders won't work. So I guess I'll wait. Yeah, this is all kind of messy stuff. Do I, I'm just trying to decide, do I want to do breaking changes now? I mean, it doesn't really matter because I can switch back to the other branch if I needed to test something, but I guess I can't, but I couldn't show it on stream. I guess let me just go ahead and do it so I don't forget. Okay, yeah, I'll need to clean up this class later. But I kind of want to, yeah, I want to just get this working, and then we'll have like a super simple material shader just to try to start testing everything again. Okay, so one thing right now is our shader doesn't actually have any properties to affect all this sprouting stuff. So I need to add basically all these, and then, okay, so this should be sprout. LED noise. Okay, and then I also need to have the sprout yeah, data map. Okay. Okay, so this is just the basic. I pretty much just copied it. It doesn't actually do any of the sprout stuff. If I remember right, here, so here's the instance lit version. Oh, that's the shader. Yeah, so this is pretty, yeah, so this, mostly this part is not very clean. I feel like I could make this better. But, okay, this should really start with the forward lit pass, since we're going to need all the lighting stuff. Oh, but I want to copy or delete the old one because I'm going to paste it on. I was gonna see, did I do anything? No, I just included the common file, which I can add back. I don't think I need either of those. Okay, so so this, yeah, we have some of the shadow stuff. I'm just trying to think. It shares a lot in common with the normal lit pass, so, but I don't really know if there's much we can do to try to share code. I was just thinking for like some of these if statements, but maybe, I don't know, we might just make things more complicated. I guess I could put things like the shadow chord and some of this other stuff. Yeah, some of these other values probably. Okay. Oop. I have to change the name here. Or file extension. Okay, so I think I'll just grab a lot of the things that are in this file. And I'll move this into the other folder. So I could do a macro for this. I don't really know if it super helpful. Oops. And these helper functions. Okay, so one problem now is these don't know about the interpolator's structure. So it's not a huge deal. It just makes it a little bit more verbose, so I just have to ask for the world space position and then the clip space position. And then if I want to get back to the old method, I can just do use a macro. So we do define, if I can find the right key. Because macros don't really care about the type, so. And then in this, instead of calling, do this. And basically a macro replaces this string with this string. So we have to do something similar for this one. Do float for shadow chord, and then float for our 3 position world space. And then down here, just do that. Okay, so I'll do something similar with this. Calculate GI. Probably how I'll do it is there's not really much reason for this to be a structure, like a function itself, so although I guess it kind of does, because I don't think I can I don't think I can define a macro to refer to another macro. Okay, well, I mean, it's not a huge deal. It's a little annoying, but okay, so static, light map UV. Okay, let's just use the same names. Okay, and then I would do trying to figure out what to name this. Okay, and then this one doesn't have dynamic light map, so we'll just pass the 0 there. Okay. Okay, let's see. I see it right here. It's giving me an error that can't open that file, but oh, for some reason there's 2 versions. Oh, sometimes this happens. Let's see. Oh, well, I don't see it. Let's close both. But sometimes when you move a file in Visual Studio, Unity, or I don't know, maybe Windows, so somebody keeps the old version around. Okay, can't open. Okay, so it's just saying in both of these, the lit forward pass and then the sprout pass, it can't open the lit pass common file for whatever reason. But I thought we tested that you could do the double dot. Oh, I forgot the common file, our common folder. I think that fixed it. Sometimes, like I said, the... Okay, no, it didn't. Oh, okay, well, it did fix it, but now we have other problems. So it says ambient occlusion factor doesn't exist. What version am I in? Okay, so it does exist in this version, but maybe... Yeah, this should probably just include the lighting file in case it hasn't been. Probably... I guess the simple lit comment should, which I thought I did. Okay, so yeah, the let pass comment does. Too many files open. Okay, so this does not include the lighting. Wait, although let pass comment does. So where is... I don't even know where the foliage lighting is being included. Okay, well, that's an old shader. Okay, maybe it's actually because some of these other errors are preventing it from compiling or something. Let's see. Shader error, invalid subscript. Okay, so get shadow chord fragment has something. Oh, okay. This is a similar problem because, okay, so yeah, I don't think I need this function at all, actually. So what I should do, okay, so if defined, then yeah, I'll just kind of move this around. Because the problem was, it was throwing that error because the input function, or input structure didn't have a shadow coordinate. So yeah, I have to, before I called this, I have to make sure that we're in the correct, or the correct keyword exists. And yeah, now I can just delete this. And I think I can, it's not quite as important for this version, but I mean, might as well. 0. And recognize identifier get shadow chord vertex. Oh, I forgot the define keyword. Subscript. Lightmap UV. Oh, right. Okay, this is another. Keyword problem. Okay, so the problem is that if, depending on if the light mapper is on or not, then we won't have this vertex. So I guess what I would do. The thing is, I don't know. I don't think macros can reference macros because it seems like that would cause like infinite looping. This is kind of a shame because I don't really want to have to write or handle both of these cases, but well, okay. Let's see if this works. I don't think it will, but too many arguments for macro call. Okay, yeah, so that just makes me think that it doesn't like okay, I didn't really want to have to do this, but I guess the best way is just to do an if else thing here. There's got to be a better way to do it. I mean, I guess the better way is just to kind of make my own macro. But I don't really want to have to do this either because, like, if Unity ever changes the sample GI macro, this will break. Or the functions behind it. But maybe it's not too complicated. Let's see. Okay, and also, yeah, I'm not even on. Yeah, the 2021.2 where we have the more complicated version. Okay, see, so this is pretty simple, but when we have the dynamic light map, it adds another argument, but well, I don't think I have a choice, so. Well, let's see. So what's actually, it's really a version thing, isn't it? So, yeah. Okay. Well, I know I just kind of went back on what I just said, but I think this is probably the cleanest way to do it. So yeah, either way, we'll just use Unity sample GI. And it's annoying because the only difference is that in older versions, there's one less argument, but okay, that's fine. We'll just delete this, and I'll just comment this out in case we need it for some reason. Oh, okay. Yeah, so that's kind of the reason why I didn't want to have to do this, because now I have to update each file if that ever changes, but hopefully it won't. Okay, so it's still saying there's no ambient occlusion factor, which I'm pretty sure is not right, because they use this in here. Oh, do they not really? What? I thought I tested this already. What does... Oh, they don't use it if screen space occlusion is off. Okay, so it's not... Oh wait, did I just... So how... Oh, it's on selection. So if I change it to the current document... Okay, it does, okay. I thought maybe I had done a typo. Wait, but here it is right here. Did I just do a typo? Because here it's clearly defined even if screen space occlusion is off. Okay, well, I don't know where this is being called without the lighting file being included already, but I guess it's not like it hurts anything if I include it again. Oh, right, and I can get rid of these now, because I put them in the common file. Okay, this is just a simple normal map calculation, which I guess I could just put in the math file instead of the simple lit common. Because I don't think they're... Well, okay, it does have this normal strength. Oh, I'm sorry about that. Okay, so what I have to do is just add another argument for normal strength here. Well, I guess I could, in this file, just leave it how it was. But then this folder will just, this file we'll call the other version. Okay. Gosh, more errors. Implicit truncation. Not implicitly convert foot 3 to foot 3 by 3. Oh, okay. I think this is just because it doesn't include the math file. So what I should do... Not implicitly convert foot 3 to foot 3 by 3. I thought it would be smart enough to know that this version has 6 arguments, but this one has 7. I'd like to see if this error goes away if I did that. Okay, yeah, so this stuff we don't really care about. Actually, most of this lighting stuff we don't really care about because we're going to use different lighting, but... Okay, so that problem I saw before was just the error is not updating. Oh, wait, so that did matter adding that one. But why does that... Okay, how come it doesn't... I mean, I guess the easiest way is just to rename this. But I don't know why this, like in this sprout pass texture base, it's throwing an error, but not in the simple lit forward pass. It doesn't seem to care that it's like it gets the values correct this way. Maybe because the normal strength isn't defined. Oh, okay, yeah, it's because this file isn't included in the sprout pass texture base. So yeah, okay. So this is actually, yeah, we have to add the normal strength. Okay, yeah, that was. Okay, so now we have nothing, oh, no more errors here. Okay, so I guess we just need to update this to actually do the sprout logic. So the main thing is I need to have this culling value, or yeah, this culling position, and then the clip dimensions. Okay, so I forget, how is that different than the normal clip space? Oh right, we're transforming to basically to view space of the real camera instead of the virtual camera. Okay. So I guess we can, so this UV is just 2, so yeah, we can pack the clipping dimensions into there as well. And then we'll have to have the culling position and clip space. Oh, I'm not even gonna put clip space because it's like in a totally different space actually. So yeah, we cut text chord 8. So I think what I want to do is put like this. Okay, well this is this is like the max width and height of a blade. But okay. But yeah, I think I want to put as much of this logic into a helper file as I can. I think it should go in the sprout pass common file. Float to calculate dimensions, and then we'll have blade size and float. Oh wait, so yeah, we already have the culling transform, so yeah, we don't even need to pass it. And then float for calculate culling position. And that's basically the same thing, except we're using the complete, oh, I guess, yeah, we're keeping all coordinates and we're using the position instead of half dimensions. Alright, so this is actually a blade size divided by 2. Okay, and then in here, okay, and this is actually based on the sprout data map instead of the color map. Although, I guess they'd all be the same, so. Alright, so now we got culling dimensions and the culling position, which are, I think, really the only special things we need. Okay, and then the fragment. This is all like for lighting, so we don't actually need to calculate this yet. I think I'll move this into its own function. So float 4, calculate lighting, and yeah, I don't know what it'll pass to it, but for now I'll just comment it all out. Okay, so the first thing I need to do is we need to see if this pixel is culled for whatever reason, either because it's out of view or the LOD grid. Oh, right. Okay. And this is a tip that took me a while to find out. But if you tag your fragment function with that, then the shader will actually not run it if it fails a depth test, which is going to be kind of useful for this. Because let's say, like, if you have a rock on the terrain, you don't want grass to spawn beneath the rock. So that's what this does. Okay, so do I not like anything about this? So I change this to culling position. Which, now that I think about it, doesn't really match here. Okay, let's change it to like culling space or something, I don't know. Wait. Actually, do sprout culling position. I think this is a little more obvious. Yeah, because the system is confusing enough. I'm hoping that when I can change, or when I'm done rewriting all these shaders, it'll be slightly more obvious what's going on. Okay. So now, yeah, if it's not culled, then we'll okay, so then we'd actually go forward. Okay, so now we're gonna test like density. So we would sample the control data. Okay, so yeah, for our random seed, we want to throw out the altitude. Although I guess it doesn't actually matter. Yeah, I was trying to think, because originally I had it so that like if the terrain moved up and down, the grass wouldn't like. So basically, what happens is because since the position determines all random values, including like the blade's orientation, it would kind of spin around when you moved up and down. But I think the system is really only going to work for static grass anyway, so. The only other way you could implement random numbers without like using the position would be to use like texture, like a texture on the terrain. So yeah, you'd have like a random number like actually on the terrain, which is kind of interesting, but I might actually look into that. But for now, I think we'll just keep the system I already have. Try using random numbers built into terrain instead of using position. Okay, I guess it should be try using random seeds built into a terrain instead of position. Okay. Yeah, so I don't really see a reason to not use the Y value for this. Then we get the UV, and then we sample the sprout data map. Why is it LOD? Because this is in the fragment, so it doesn't need to be LOD. Okay, I'll have to look and see if there was a reason why. Okay, and then we check. Okay, rename that. So basically basically the R component or red component in this texture is like a percentage chance for grass to spawn at this on that pixel. Why don't we add like a sprout density value? I should really be updating the here because I have all these options for the LOD. Okay, so do sprout properties. Is there anything else? Oh yeah, the blade width and stuff. So I know I have like width and variance. Another way we could do it is just have like a float 2 for like the minimum and maximum width. I don't know what is better. I guess it's kind of just what's the term? Preference. Okay, so next after that we do like all the logic about the actual sprout, and I had decided that maybe we don't even need the sprout setting structure, which used to, it was a big structure that you would pass to this add sprout and it would do some stuff for you, but it's pretty much just passing values from the structure into the grass sprout structure, so I don't really know if it actually helps very much. I mean, I guess the only difference is there's a couple values that don't need to be included when you have instance lit turned on. But I don't know if that really matters because this shader is only going to be for instance lit version anyway. So what I want to do is try to... Okay, so here we get the normal and tangent from the terrain. And why do I need that? I guess just to do a normal map. Okay. So I guess you could conceivably want the normal for the terrain to be different, or the normal map for the terrain to be different for the sprout shader than from the material shader, but I think just for simplicity they'll be the same in this one. Okay, now I do need the tangent and the bitangent because we have this grass scatter. Let's see. Unfortunately, because I want the bitangent to be the same one that Unity uses, but I don't think there's a way. They don't have a function get bitangent. Yeah, so I mean it's basically just a cross product, but then we have this flip sign. But technically you can also get the bitangent from the third excuse me, the third row of this matrix. So maybe that's what I'll do. So I can change this get. Okay, oh no, I guess we'll just leave it like that. And then, but what I'll do here is we'll call that apply normal map. Okay, so now we have a normal map and then the deformed normal vector. Okay, and I'm gonna kind of ignore the lighting for now. I guess really I shouldn't even worry about this. We should just test kind of what I have. In fact, I kind of think we should just test maybe just with not even culling or anything. So, okay. But let's just add like a really simple sprout. Okay, and then add sprout. Okay, and let's just turn off all of this for now, and we'll just return black. Oh. Oh, right. I renamed these. Oh. Yeah, a little typo there. Variable sprout used without having been initialized. Oh, yeah, I meant to put 0. Okay, implicit truncation of vector type. Oh yeah, this needs to be a flip 4 now. Okay, so let's just make a test scene. I already have this one, but I think I want to start. Well, I guess this one's already set up, so. Well, okay, I'll leave this and then I'll make a new one. Oh, I already had. Okay, so I press play. Nothing happens. Okay, so yeah, this shader, this fragmentlet shader should work already. But maybe I'll just make a really simple one just so that any like baggage that's left behind in these old ones doesn't mess up what we've got going. Okay, so this will be material, or I guess I'll call it blade. Yeah, this will just be instance lit. Oh yeah, so this is gonna also have like versions with tessellation, versions without tessellation. So we'll say no tessellation, instance lit. Okay, so you don't need a sprout pass for sure. This won't need a meta pass because it doesn't exist in the editor. Okay, I can use depth normals and depth only, but I think I'll comment them and shadows for now. Okay, and then since this one is instance lit, it doesn't need basically any of these lighting. Okay, still kind of want to do something with the debug display, but I'll comment that out for now. Alright, so I want this one to just be basically the simplest possible. So yeah, because you could have like a version where there's like no lighting, but maybe it has screen space ambient occlusion for a, well, I don't know, that would be difficult to do, but we'd have to separate the lighting between like baked and not baked, but alright, yeah, so let's just get rid of all this for now. Yeah, no instancing actually in this shader. Okay, and this will just be blade. No tessellation. Instance. I wonder if there's some way that I can just, if I want to add tessellation, I can just like do like a special file, but we'll just go with this for now and I can change it. Oh, right, I need to, okay, can't really do it in Unity, so I'll just do it here. I need to change the file type to HLSL. And I'll just start off with the simple let depth only pass. Blade. Okay, so this actually won't need common. Really, it doesn't even need. I'm trying to think like what. Okay, I guess I should leave the lighting in there because just so we can have like the standard URP values. But it really. Oh yeah, see, it doesn't even use these like standard structures because it just reads everything from the compute buffer. So let's look. So it needs to have this struct for sure. foliage lighting and my custom lighting. Oh, it was. I think it was just to make it so I could compare them, but I'm done with that for now. So yeah, we don't even use the positions in the same way. Okay, well, I guess we still do have the fragment structure. Yeah, just no attributes. I'll call it interpolators. I don't need UV. Yeah, I just need color, basically. Oh, yeah, I guess in the future I'll need UV because we'll read a texture to do like alpha clipping or whatever, but yeah, it basically just reads a bunch of stuff. But what I really want... Okay, so these are helper values come from this grass draw common. Okay, so let's make... I guess I could just copy and paste it. Oh, yeah, I guess I can go in here. Yeah, so actually, I'm gonna just comment this out for now, but I don't, like I said, I don't think I'm gonna do wind in this shader anymore. I think it's actually gonna go in the sprout shader, but I'll have to get back to that. So I think we can just copy or comment out most of this stuff. I mostly just want... yeah, these functions. Okay. Basically what I do is we calculate the tangent space of the grass card using the dimensions. Why do I need the dimensions for that actually? Because yeah, the dimensions... Oh no, I guess this is fine. Because yeah, the dimensions could just be multiplied in here because the tangent space and world space have the same scale. They're just rotated differently, so... Oh yeah, and to get the vertex ID, I have to use this semantic instead of getting an attribute structure. Okay. Right, and so yeah, the way you do this is you basically just tell the GPU that you want to draw a material with this shader, and then you have to tell it how many vertices you want. And so basically for every sprout that gets created, we say that each sprout has 4 vertices, and so that's kind of what this is doing. That's because each sprout basically just makes a quad on the screen, which I call the grass cards, but oh, this is the old one. Yeah, I want to make sure I don't edit that. Okay, so now I need to transform the tangent space into world space. So I guess the easiest way to do that is just multiply. We have the sprout. And I think it has oh. Okay, the way this is... Okay, so I guess in order to save data, I only included the bitangent and tangent because you can figure out the normal vector with their cross product. And the terrain normal. Okay, well, this is all going to change anyway. In fact, I could just kind of comment this stuff out for now. Okay, so what's like the bare minimum I need? And we'll add things back. We need position. We need, yeah, like a way to generate the tangent to world matrix. But what? I'm trying to remember, like, why did I name these differently? Let's see. Oh, right. Okay. It's because the terrain normal is for lighting. It's not necessarily the way that the grass is pointing. And okay, that makes sense. Okay, well, I mean, that's fine. But we're actually... I think we'd still need it for wind, but maybe we won't need it if it's not... I mean, if it's instance lit. Okay. Well, yeah, scared to be too destructive here, but I guess I'm already gonna change the way some of this is done, so. Okay, so we got the position, the tangent, bitangent, and dimensions, and I think that's all we need for now. I guess we'll need the tent, because that's where lighting will be stored. And yeah, we won't worry about those for now. Okay, and whenever you change the structure, you also have to change the C# version, which is... Yeah, I need to probably change all that stuff, but the C# stuff you can kind of keep separate for now. Okay, so we have the mesh lit version and then the instance lit version. I don't really care about the mesh lit for now, but we got rid of that. Got rid of these. Okay, so I guess I'll just keep the old one around. So you have to tell it the size of the structure because we're gonna make a compute buffer out of it. And so you basically just have to count up the number of floats. So we've got 3. We'll just start over. So 3 plus 3 plus 3 plus 2 plus 4. Okay, actually I changed these as well, so this can be depth only. I think I call this route pass. Yeah, I'm glad I noticed that because that would probably cause me some issues later. Okay, so we've got to make that matrix. Float 3, card normal is cross sprout card. Okay, yeah, we're gonna need to like make sure that I haven't like reversed the normal, because yeah, when you work with cross products, you always have to worry about right and left hand rules. But for now, we'll just go with this. So card tangent to world equals. Oh, I'm having so much trouble. Typing this stuff. Oh yeah, that wasn't even correct. Okay, so now here we multiply the matrix by the tangent position. Oh yeah, I don't have to do that because it's just a float 3 by 3. Okay, and then we can calculate the clip space position of this. I think this is the function for this. And then the color is just the route tint, and then here we'll just output the color value. Okay, so let's see how broken this is. Couldn't open tessellation instance lit. Let's see. Well, it should be right there. Oh, well, I forgot the HLSL on there. Maybe that's the whole problem. Okay. Alright, so I just didn't rename some variables there. Incorrect number of arguments to... Oh. Yeah, so this is a 3D UV because it was using okay, so I don't even have to do that because that was for texture indexes, which we don't. Like if we had a texture array, but yeah, we don't right now. Redefinition of position tangent space. Oh, this should actually be position world space. Doesn't exist. Okay, so we gotta go find that function and what the actual name is. Probably look in space transforms. Okay, there it is. Okay. Oh, transform world to H clip. Okay. So now I need to make another material for this. Let's actually just put these in a folder. So, version 2. Super simple blades. Oh, I did. Did I? Oh, okay. Okay, so I still have a bunch of stuff I don't need. Actually, we don't need any properties at the moment. Now what? That's like something... Uh-oh. Did I... This is still the old one. I don't know why it's like just not telling me of that error because it's gonna be kind of old. Okay, I'll just ignore that. Alright, I wasn't even done yet. So here we've got to put the new material here for the blade shader. Alright, so nothing so far. It's always a little difficult to diagnose bugs whenever you're doing anything. Kind of like a compute shader, but okay. First problem is, yeah, when you use the frame debugger, you kind of need to have it open. So this is drawing our depth only. Oh, okay. Here's the grass sprouting pass. So at least we know that's running, but we don't really know if it's sprouted anything. Okay, so opaque objects. Okay, so it does do our draw procedural, but it doesn't really tell me anything about it. Alright, so yeah. It says it's not compatible with the SRP patcher, which I definitely want to fix, but we'll have to figure out why that is. But anyway, so it's drawing our grass. Well, at least it's getting called. So that makes me think either the sprout size is empty or there's some other problem. Let's okay, I suppose that the alpha is always 0. Not that that would really matter. Oh, there was a bug. Or no, I just introduced it. Okay. Not so it says it's not compatible because blade width is not declared in the shader property section. Oh. Okay. Well, we can fix that, but yeah, I think what it's complaining about is basically these properties don't have, or these variables, even though they're in the Unity per material constant buffer, don't have a property here. So I mean, yeah, we'll get to that, but I really want something to appear on the screen before the thing is over. So yeah, I think I need to test that first. So I think the easiest way is like here you can see I've kind of done similar things. We can make sure that some sprouts are actually being pushed to the array by here. This is really bad to do for performance, but it's fine for debugging. We just download the a buffer every frame and print it out. So this 0, or this first argument, should be the number of blades each frame. Okay, so yeah, it's saying that there's 38,000 or 385,950 blades each frame, or vertices actually. Okay, so at least I'm glad to see that there's something in there, but oh, you know what? I think actually the problem is everything might be working, but on our sprout pass, the dimensions are always 0, which is a problem. So let's just put some kind of dummy things here. Position world space equals input position world space sprout dot dimensions equals 1 sprout card tangent is the x-axis, hard bitangent, the y-axis. What else? And then the tint. Let's just put green, I guess. Oh, I think I need to have the world space suffix on there. Don't care about the flag at the moment. Okay, well, still nothing. Now what I would do is like get the data out of the grass structure and then print. So let's just make sure that the position is something sane. What? Oh, yeah, it should be direct instance lighting. By the way, this is set to use, yeah, for instance lighting. Is there another bug? Apparently. Oh. Okay, so we can see we have a bunch of floats and they look like they kind of make sense, but I don't see. Oh, okay, so we have a square. But even though these positions are all different, the square is always at 0, 0. So, and judging by my computer fans, there's also a lot of the squares right in that position. So that would make me think that the problem is actually in our blade lit logic, and I think I know what it is. So here, if I can find the right file. So when we find the position in world space, we only rotate the tangent position, but I also need to offset it by the sprouts position world space. Okay, and now we can already see some. So there's this kind of weird artifact right there. I'm not worried too much about it because we're gonna. I don't know what is causing it, but yeah, there's a kind of weird effect. Huh. It's almost like it doesn't want to spawn in the shadow of this. Okay, so I guess that is it. Oh yeah, so okay, this must be marked, like it must use a... Oh, you know what? Seems like they're both being occluded by these lit objects, which is kind of funny. Why would that be? Because these don't have a sprout pass, so they... I wonder if they're messing. they're just using the lit shader. Let's yeah, here. Let's change the dimensions to something a little smaller so we can see a little better. Yeah, so that's funny. It definitely is being occluded, but yeah, it only updates if the game view is visible. Okay. Oh, okay. The reason that's happening is because of the this is the grass system. I think they're being culled because we're seeing the back face on this side. It's yeah. Yeah, we need to turn culling off of the material shader. But yeah, this is just it's a funny bug I wasn't expecting. Let's see, so here we need to just turn culling off. And that's because, like, in the final version, these blades will all be twisted around, so. But this does kind of illustrate how the system is working, because there's a camera from above that's raycasting down. So if this object blocks it, the grass won't spawn. But I am surprised that the grass isn't spawning on top, because normally that's what would happen, but yeah, because these aren't even using a soil shader. Let's see, if I gave... I see, if I gave it the soil shader, then the grass does spawn on top of the sphere. What about if I turn off a depth prepass? Okay, so that's the reason why. Okay, so that makes sense. The reason that that gave me the aha moment is because last stream I guess I decided that we might not need to have a separate like grass depth pass for the sprouting, so we could just use the same depth only pass. So I think what's happening now is, since these shaders have a depth only pass, they're also occluding the grass. So what I need to do is, I'm not sure if it's, I'll have to maybe look into it and see, but on the grass feature, we'll basically have to use, we'll only want to run the depth shader tag on, or we only want to run the depth only pass on things that have a grass sprouting tag. Let's see if there's an easy way to do that pops up to me. Okay, so maybe create draw settings. Well, so I want to use this tag, but where do I? So I think this is telling it to also draw. Oh, what? Because basically I want to say only if a shader has, I guess I have to check to see if it has both tags, but if a shader has the, I don't know, maybe I shouldn't do this. Maybe they should just say different passes because it's most simple. Yeah, that's probably better, because if you have the... Because if you have like an invisible sprout shader, you don't really want it to be drawn in the normal depth pass. So yeah, it should have a different name for that reason. But they can be kind of a copy. A little strange, but let's see here. So depth only. Let's make a grass depth or sprout depth only. And yeah, it could be basically a complete copy. Well, do I even have to copy it? Can I? Oh no, I guess you can't have like light mode, depth only, and light mode. Sprout depth only, so. Let's just say grass sprout depth only. Okay. Yeah, so now these aren't occluding the grass, but if I give this the sprouting shader, they do, which is what we want. Because like imagine this was a rock. We don't really want grass to spawn under it. Because if I turn off the pre-pass option, then the grass blades don't get occluded anymore, but now there's blades like inside this sphere that you can't see, but they're still taking up you know, rendering time. So yeah, if we have that turned on, then the system's smart enough to know that something is in front of it. Okay. Well, I think this is probably a good place to stop. I feel like we made some good progress, finally got something shown, so we can start to get to the more fun stuff. So I think for now I want to do just a simple instance lit shader, and then I want to try that new wind thing I have in my head, or I guess wind technique. And then after that we'll start doing more complicated lighting and just work back up from there. But yeah, I guess thanks everybody for coming by and watching. I really appreciate it. I do hope this grass stuff's not too boring. I think it'll be more interesting now that we've kind of gotten something actually to display on screen. So thanks for sticking with it. But I'll put some links in chat if you enjoyed the stream and you'd like to connect with me on social media. I do check out my YouTube channel where I post game development tutorials. Yeah, I have all kinds of stuff there. So, but yeah, I'll be back Wednesday at same time around 2:30 US Eastern. And until then, have a great day. Bye-bye.